Okay, so let's go. Today we're going to talk about problems type 2, moles to atoms. We already talked about how that's a two-step problem. So let me give you one, and we'll set it up together. How many atoms are present in 7.56 mole of ammonium hydroxide? So yesterday, you guys who were in class, or if you watched the video, I had you put a box around what you knew and circle where you wanted to go, just to kind of keep yourself straight when you're setting things up. So my box shows my given, my circle shows my where I want to go. We already established this is a two-step problem. In my first box, I always put my given, so I have 7.56 mole NH4OH, that's ammonium hydroxide. Eventually you guys will learn how to put those all together. We treat this just like it's over 1, just like you would in any math problem, so that makes sense to you mathematically. And then say to yourself, where do I want to end up? Anybody tell me, where do I want to end up? Atoms. So that always goes over here. Atoms, NH4, I'm going to run out of room, OH. And what do I need to cancel out up here from this box?
Moles.
Moles. What's the only number I can use for moles unless I'm given something different? I heard Josh say it. Number 1. So my 1 mole goes down here. Now this next one you have to think about just a little bit maybe. What number do I use for atoms?
6.0.
Yes, 6.02 times 10 to the 23rd. In my personal opinion, these are the absolute easiest ones because you never really even have to use your periodic table. Whose number is this? Avogadro's. Emilio Avogadro, actually. So, let's look at what I do with this. What's 1 times 1? 1, so I'm going to be dividing through by 1, so that really means nothing. So I take my 7.56 mole times my 6.02 to the 23rd. You have to be careful when you put this in your calculator. Be sure that Avogadro's number is, that everything's in parentheses, because your calculators act a little weird with exponents when you do these problems. So I'm going to put it in mine and make sure we all get the same thing. You have an answer? Anybody?
Maybe.
Maybe?
A little bit. Okay.
I would say you people with those little tiny red calculators, it's about time to make your jump to the big boy calculators.
Well, I have a big calculator.
What'd you get for an answer, Carter?
Well, I had a little e in my book.
Yeah, that's exponent.
It's exponent.
Yeah, so that's your power of 10.
I had 4.55112 to the power of 24.
Okay, anybody else have that? Let me check here one more time.
You got it right.
I haven't done it yet.
I'm just trying.
Well, I think it's
I just
right.
typed it into my calculator, parentheses and all.
4, I would call that 4.6.
Oh, yeah.
Yeah.
4.6 times 10 to the 20, what was it, 4th? Yep, 24th. NH4OH. If you want full credit on these problems, when we test, quiz, whatever, I need to see this.
I hate this.
I need a box around your final answer.
What if I circle it?
Will that be okay, as long as you point out what it is?
Okay.
So that's one way it will show up Any questions about that before we go to the next one? Okay, so then let's look at it the other way. Um, Okay, how many mole of sodium chloride are present in 9.8 times 10 to the 27th atoms of NaCl? Now stop and listen to this for just a minute. This could also say particles. Same thing, don't let that throw you if it happens to say particles in a question. You go about it in the same way. Atoms and particles are interchangeable. So, obviously it's a two-step, we've established that. I have my box around what I know. I have my circle around where I want to go. I should be able to set it up. Try to set it up, but don't do the math yet. See if you can put things in the right boxes. Okay, let's talk about the setup. What goes in my first box, Carter?
9.85.
Yep, 9.87 times 10 to the 27th atoms of, what did I pick, NaCl. Ooh, Rowan, what has to go down here then, since I have atoms up here? What do I want to cancel out? I want to cancel out atoms. What's the only number I can ever use for atoms unless I'm given something else? What did you say? Yes. 6.02 times 10 to the 23rd atoms. Good. And that is how many atoms in what?
A mole.
1 mole. Good. So 1 mole goes up here. 1 mole of NaCl. Because I want to end in moles, and the only thing I can use for moles, unless I'm given something in the problem, is 1. Now do your math. So I multiply by 1, and I divide by 6.02 times 10 to the 23rd. So here's how, let me tell you how I would put, would I copy, oh, there's no 7 there. Sorry, guys. So I'm going to put it in my calculator this way. 9.8 times 10 to the 27th, then hit your enter button, and then hit times, parenthesis, 6.02 times 10 to the 23rd, parentheses, enter. See what you get. This is multiplication, and then we divide by this.
Okay. Okay. Let's see.
Got an answer?
No.
Yeah? No?
Well,
What?
I found an answer. It may not be the right word.
I don't think our name's back.
Who's brave enough to tell me their answer besides Josh? He's always brave.
No, because it says, are we supposed to multiply 9.8?
Times 1 divided by 6.02 times 10 to the 23rd.
I got 16,279.
That is not.
16,279 is point 1
Yeah, come
is the correct answer.
on. Hey.
Carter, did you have this set up?
Yes, I think I divided the problem,
Did you?
There's
Did,
no point of multiplying it by 1.
no, you don't really have to.
maybe. Oh.
But that's what that's telling you to do.
Yeah.
But the multiplying by 1 makes no difference. You're right.
I used the wrong exponent.
Oh, well, that would explain it. So anyhow, how you guys at home, this is the correct answer. If you want to be even more correct, since you start your problem in scientific notation, you really should end your problem in scientific notation. So that would make this 1.6 times 10 to the 4th mole NaCl. Okay. Ready, guys? Tell them goodbye.
It's a little upside down.
What's the screen?
Oh, well. Okay, we tried. Have a great day, people.
Wow.